Today we'll continue our exploration of quadrilaterals by looking at rhombi, although also known as rhombuses, rectangles, and squares. Let's review a little bit of quadrilaterals first. All quadrilaterals have four sides, four angles. So these are all examples of quadrilaterals. They all have four sides, they all have four angles. The interior angles of quadrilaterals all add up to 360 degrees. So if I take all four angles and add them up in any quadrilateral, any four-sided figure, we can get 360 degrees. A more specific version of the quadrilateral is the parallelogram. Parallelogram is a quadrilateral that's composed of two sets of parallel lines. So we have one pair of parallel lines and another. They create a shape, a parallelogram. Because it's made of two sets of parallel lines, opposite sides are congruent and parallel. So not only do they never touch, if you extended those line segments in both directions, they're also the same size. Opposite angles are also congruent. So that pair of angles, congruent, the same measure. That pair of angles, congruent, the same measure. Parallelograms open us up to look at a lot of more specific parallelograms. In order to take the next step, let's look at parallelograms as a whole. To find the area of any parallelogram, it's very simple. It's the base times the height. So area equals base times height. In this case, the base could be either of those two sides. I know that this side's 5 centimeters. That means the top side of this parallelogram is also 5 centimeters. The height, if it's not straight up and down like a rectangle or square, you have to find a line that goes straight from the highest point of the shape down to the level of the current base. So we drop in a line. Oftentimes in a problem that involves area here, we'll be given this value. So this is going to be 6 centimeters. This is how tall the whole object is. The base is just one of the sides. This is similar to the altitude in the triangle. When we found the area of a triangle, if we weren't given a right triangle, we didn't have a straight base and height. So we had to drop a line from the highest point perpendicular to the base. So now that we have our base and our height, we just multiply them together. Area is base times height. Base is 5. Height is 6. So I get 30 centimeters squared. Area is always centimeters squared, or always units squared. Rectangles are a more specific variation on parallelograms. It's a parallelogram with 4 right angles and 2 pairs of opposite congruent sides. So opposite sides are congruent and parallel. All angles are congruent. So that means they're all right angles. If I take 360 degrees and divide it evenly by 4 different angles, I get 90. This still follows the rules of a parallelogram. The opposite angles are still congruent. In this case, all angles are congruent though, 90 degrees. If I wanted to find the area of a rectangle, it's still a parallelogram. So I just take base times height. So area is base times height. With a rectangle, though, it's a lot easier. We can see the base and the height because they make a 90-degree angle. We know that the height, even if I have to drop an altitude, it has to be perpendicular to my base. So let's look at an example. Here I have 6 inches, here I have 3 inches. My base is going to be 6 inches. My height is 3 inches. That's how tall the shape is. This gives us 18 inches squared. The unit is always squared. With rectangles, some people will change the formula to say that area is length times width. But since it's a parallelogram, we can look at the same idea. We need a base, which is a nice straight side, and we need the height, which is perpendicular to that base. In this case, 6 and 3 meet those requirements. A rhombus, or rhombi, goes by a couple different names, is a parallelogram with 4 congruent sides. So we have 4 sides, which means it's a quadrilateral. All 4 sides are congruent. So that means opposite pairs are congruent, opposite pairs are congruent. It still meets the requirements of a parallelogram, but it's more specific. Now all four sides are congruent. We still have opposite angles that are congruent, just like every other parallelogram. Those are congruent, the same measure. Those are congruent, the same measure. Since a rhombus is a parallelogram, we can use the same formula for area, which is base times height. In this case, because we don't have perpendicular lines, we don't have right angles, we need to drop an altitude. Now, an altitude doesn't have to go outside of the shape. It can go inside as well. So here I'm given a base of 4. My altitude, or my height, has to be a perpendicular line that goes from the top of the shape perpendicular to my base. So I'm going to draw it straight there. It makes a 90-degree angle. That measurement is 5 meters. Multiply my base times my height, so 4 times 5 gives me 20 meters squared. The unit is always squared. Squares are a very specific shape. A square is a quadrilateral. It has 4 sides. It's a parallelogram. It has 2 sets of parallel sides. It's also a rectangle because it has 4 right angles. However, it's also a rhombus because it has 4 congruent sides. So all sides are congruent, same exact measure. All angles are congruent. 360 split out 4 equal ways is 90 degrees. That gives me all right angles. This is because it's a mix of rhombus and rectangle properties. It gets all of the congruent sides from the rhombus, all congruent angles from the rectangle. Since it's a parallelogram, we can find the area using the formula for the area of a parallelogram. So it's base times height. This is another case, just like rectangles, well, some formulas call this length times width. But since these are all parallelograms, we can use the same formula over and over. So in this case, we're given that one of the sides is 8 feet. Since all of the sides are congruent, that means every single side is 8 feet. Now, some people will shorten or change the formula for the area of a square by just squaring whatever side you know. So 8 squared would give us 64 feet squared. However, this is a parallelogram. Why learn a separate formula when it's all just base times height? 8 feet is our base, 8 feet again is our height because it's perpendicular to our base. So we just simply take 8 times 8 gives us 64 feet squared. The unit is always, 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 always squared with area. All of these shapes are quadrilaterals, but let's discuss how they're related to one another. All of these shapes here are quadrilaterals. In order to be a quadrilateral, you just have to have 4 sides. All of these meet that requirement. More specifically, we have some shapes that are parallelograms. In this case, they have 2 sets of opposite sides that are parallel. We know from our studies with angles that parallels cut by transversals create specific and important angle relationships. All of the opposite angles in all of these shapes are congruent. The opposite sides are parallel and they're also all congruent. Within parallelograms, we can break the rules down even further and make them more specific. These are rhombuses or rhombi. With rhombuses or rhombi, all of the sides are congruent. This still follows the rule of parallelograms where opposite sides are congruent, but now we have 4 congruent sides, not just 2 pairs of congruent sides. Some parallelograms are rectangles, which means not only are opposite sides parallel, not only are opposite sides congruent, but all 4 angles are congruent. When they're all congruent, so 360 divided by 4 angles, it gives us right angles, 90 degrees. If all 4 angles are congruent, that means it still fits that rule within parallelograms. The opposite angles are still congruent. In the center, where rhombuses and rectangles overlap, we have squares. Squares are quadrilaterals that are also parallelograms with 4 congruent sides, 4 congruent angles. So it is a quadrilateral parallelogram rhombus rectangle. So we can look at this. All squares are rectangles, but not all rectangles are squares. All squares are rhombuses, but not all rhombuses are squares. They share some of the properties, but not all of the properties. Regardless, rhombuses, squares, rectangles all share the general rules of parallelograms. Given